Greetings and welcome to Edu-ca-te. My name is Pilani Gabriel Mapiro. Stay tuned. Today we're going to be talking about quadratic number patterns. Okay, so what are quadratic number patterns? Quadratic number patterns are just those number patterns which have a constant second difference. So let's try to put it into more perception. Okay, so the general rule for finding quadratic number pattern is given by Tn is equals to an squared plus bn plus c. Okay, so we'll explain why the formula is like that later on. Okay, so first of all, let's give one example. Okay, we've got 1, we've got 2 here, we've got 3, we've got 4 and 5. This is the first, and then we make a line here and draw a table-like structure. Okay, so at 1 we've got 2, we've got 5, we've got 10, we've got 17, and we've got 26. Okay, so if we have something like this, number one thing you should notice is that this is the term number and this is the term position here. So here to check out the difference, we have to first look at how much do we need to add to get to this number, how much do we need to subtract to get back to this number. So we do that by subtracting this term from this term. By doing so, this is 26 minus 17, we get 9. 17 minus 10, we get 7. 10 minus 5, we get 5. And then 5 minus 2, we get 3. Number one thing you would notice here is that this difference between these numbers is not the same. The difference between these two numbers is not the same. So we label this as the first difference because this is the difference we get when we subtract the terms from each other at first. So when things are like this, how do we get to the solution? So to be able to get to this term, number one thing we should look for a second difference. Okay, a second difference is found by subtracting this number, this sequence, which is the first difference. So it's just like this. 9 minus 7 is 2. 7 minus 5 is 2. 5 minus 3 is 2. So here we can notice that this is the second difference. So this second difference is constant. By so saying, it simply means that the second difference is the same. So it means that the first difference is different first of all, the second difference is the same. So it means we can now find our general rule. Okay, so what is our general rule? Our general rule is given by what? An squared plus bn plus c. Okay, so this a, it means is the coefficient of this number. The coefficient of this number. And then this squared, why did we put a squared here? It means we have got 1 and 2 differences. That's what makes a quadratic something. So if it's a quadratic number pattern, we have to find this number with a square here. So it means that in order to find the solution, we have just to put here a constant here. So here's a constant here. Here's a constant here. By saying so constant, it means it doesn't change. It is the same. I will show you on another video on how did they get to 2a, how did they get to 3a plus b, and how did they get to here. It's a plus b plus c here. C. Okay. So this may seem a little confusing. Number one thing is because where would you get 2a from? Okay, but then let me just show you how do you make the general term or the general rule or the equation. Okay, so it's simple, just going to start by a. 2a is equals to 2, and then divide by 2 here, divide by 2. Why do we divide by 2? It's because we want the a to have a 1 here, or we want the a to stand for itself. When there is a 2 here, it means this is 2 multiplied by a is 2 of a's. Therefore, when we divide by 2 here, we want to remain with 1a. And then 3a plus b is equals to what? Is equals to 3. Okay, so number one thing, this 2a stands for this term. This 3a plus b stands for this term. And this a plus b plus c stands for this term. Okay, 3a plus b, on a we'll substitute 1 plus b is equals to 3. Where 3 times 1 is 3 plus b is equals to 3. And to be able to isolate or to be able to eliminate this 3, we have to transpose it. By so, we remain with b is equals to 3 minus 3, which is equals to 0. Okay, so for the next term, we use this formula a plus b plus c, which is equals to what? Which is equals to this term, which is the first term of the sequence, which is 2. So where there is a, we're going to substitute this 1. Where there is b, we're going to substitute with 0. Where there is c, we're not going to put anything because we are solving for c. Okay, by so saying 1 plus 0 is 1. Why do we plus this? Is because these are like terms. All of these are numbers. There is no variable to disturb. So 1 plus c is equals to 2, whereby we want to remain with only c, not 1 plus c. Therefore, we must say c is equals to 2 minus 1. What did we do here? We transpose this to the other side of the equal sign, and its sign changed to a minus. Therefore, our c is equals to 1. Therefore, to be able to now substitute to this formula, to be able to find the general formula, you have to do this. Tn is equals to, where there is a, let me write it down first, n squared plus bn plus c. Where there is a, you're going to substitute with 1, n squared plus, where there is b, you're going to substitute with 0 times n plus, where there is c is 1. Okay. And then 1 times n squared, which means n squared plus 0n. Anything multiplied by 0, it's 0. It's like you're multiplying yourself with something that doesn't exist. 0 means there is nothing. Therefore, these two things cancel out. And then this is plus 1. So this is your general rule. Okay, how do we prove a general rule? Okay, to prove a general rule, we use this very general rule. Suppose we use it here. It's Tn is equals to n squared plus 1. Since we know our value for term 4, we can substitute directly and say 4 squared plus 1. Whereby 4 squared is equals to 16, 16 plus 1 is equals to 17. Therefore, if this answer is the same as this answer, it means that we have proven with this formula that this formula is true. So that is how you calculate a general formula for a quadratic equation. Thank you.
Let's go, boy!